Hello and welcome back to the channel. Today we're going to dive into a new environment in order to produce more electricity in a cleaner and safer way for everyone involved. As you surely know, electric is the future, from smart devices to electric cars, while electric ships and aircrafts are still in research. Electricity is usually produced by rotating magnets, and to achieve this rotation, water is usually used. In hydroelectric plants, or dams, water flows from upstream to downstream, passing through a turbine that converts a streamlined motion into a rotating one. However, most power plants work by burning fossil fuel, coal, or even trash to generate heat that is collected and redirected towards a water reservoir for it to turn into pressurized steam that, in the end, turns a turbine. The result is that we have cheap electricity, but we make the air that we and the animals breathe toxic, and also contribute significantly to greenhouse gas emissions. Renewables, like wind turbines, exploit the motion of the wind to turn a magnet, while solar panels work on a different phenomenon, but they always generate heat. Renewables, however, provide much less electricity than classic electric sources. A solution comes in the form of nuclear power plants. The basic principle they rely on is the same as all other power plants. The fuel, uranium atoms, are hit by a neutron, and the atom undergoes a fission reaction. The atom is broken and releases neutrons and heat. If a sufficient number of uranium atoms are fissioned, a self-sustaining chain reaction takes place, releasing enough heat to generate big quantities of vapor to be sent in the turbine. Clearly, if something goes wrong in a non-nuclear power plant, like an explosion or accident due to human error, the damage is limited both in space and time, while nuclear reactors can have longer-lasting consequences. For this reason, the security systems in a nuclear reactor are much more advanced and more redundant than in regular power plants. Just considering dams, Wikipedia lists more than 100 failure cases, some with very high fatalities in the order of hundreds of thousands, while nuclear reactors' failures are around 30, with much less direct fatalities, and usually due to human error or natural disasters. The pros of nuclear are that no CO2 is emitted, and just 5 grams of uranium gives us the same power as burning 400 kilograms of coal. This is what the nuclear engineers call the mega factor. A fission reaction releases 10 to the 6 times as much as energy as coal combustion. However, the worst issue of a power plant is, arguably, its decommissioning, that requires the whole plant to be torn apart piece by piece and correctly disposed of. This operation is quite costly and lasts a long time, as a full power plant with decommissioning accounting takes years, and it costs in the order of billions of euros or dollars. But wherever there is a problem, engineers see opportunities. How can we make the power plant both cheaper and safer? Well, scale them down in small modular reactors to reduce the cost, and then deploy them underwater to enhance some safety aspects. The idea of putting power plants under 60 to 100 meters of water and far from the shore could sound a bit weird and maybe new, but we've actually been doing it for quite a long time with nuclear submarines. It is not a coincidence that the company behind the project is the French naval defense company, the DCNS, that has already worked both in nuclear power plants and submarines. It is estimated that these modular power plants could produce anywhere between 50 to 250 megawatts, enough to give electricity to 100,000 to 1 million people, much less than a full ground-based nuclear plant, but thanks to its modularity, multiple units can be deployed to serve a wider population, but cheaper. The concept is straightforward, just to shrink the power plant to as small as possible and make it in repeatable units and sink it in a secure area. But if it were that easy, someone would have already developed it. So what are the issues and problems that are being solved? The first and most dangerous risk is a leak that would be much more difficult and costly to resolve, as scuba engineers could repair. However, the radioactive contaminants would dissipate in waters surrounding the reactor, and this is both great for safety, as it wouldn't affect humans, but prohibitive for the scuba engineers that would have to get in direct contact with the damaged unit. So, robots for underwater operations should be developed. Also, if radiation leaks in water, it would disperse with less probability of affecting humans, while in air, the intake probability, that is, the probability of receiving radiation by breathing, ingesting contaminated food or water, is much higher, obviously. The impact on wildlife, however, is an unknown. The few studies that are present regarding Chernobyl's exclusion zone generally show elevated rates of genetic damage and mutation rates, while Natural Geographic states that wildlife is thriving in the exclusion zone as a result of not having humans around. So this might be the time to start studying the issue seriously, as engineering is also predicting and mitigating risks for the environment. Underwater, the situation could be much more controlled. The area dedicated to the small reactor modules can be selected in advance, taking submarine wildlife into account. What can be said for sure is that the temperature in waters near the reactors will get warmer by a few degrees, and that will impact the environment close to the module. Real-world applications would be plenty though, particularly for insular countries that have not enough land like Japan or Hawaii, but also for developing countries that cannot afford the hefty price tag of billions of euros like the coast of Africa. This project might lead us closer to a zero-emission society while allowing developing countries to keep up with the electricity they require to develop. The new challenges we are presented could lead us also to new discoveries on nuclear power plants or in submarine exploration or even in nuclear propulsion. I hope you enjoyed this brief insight in the future of nuclear energy. If you did, please like and share this video and maybe consider subscribing for more new technology videos, and comment if you have any question on the subject. See you next time!